Hello, this is Mrs. Leonard, and this is the video for relationships output page that we did on Monday, September 18th. And the only materials you will need are this output page from our relationships day that we did this in class, and your notes. This is our input page that we did in class. So if you have not done this relationships input page, then you want to make sure that you watch that video first so that you can use those notes to complete this page. Okay. So I'm going to go through the first part here and then give you a chance to complete the rest of this. When we are looking at graphs in earth science, a lot of times our graphs will look like this, and I might ask you to state the relationship between the number of years in school and salary expectation. So if you look at the number of years in school, and again, if you put numbers here the way we learned when we did this on our types of relationships notes in the input page, and if you choose, put a 4 up there. So once you put numbers on the axis and then you choose a couple of points, you will see that at this point the number of years in school is 1 and my salary expectation is 1, whatever that could be. I don't know. We could add a bunch of zeros and make it like, I don't know, $10,000 a year, right? If we added a bunch of zeros here, this could be $20,000 a year. If this was 3, we could add a bunch of zeros and make it $30,000, and this could be $40,000 a year, right? And so if you're in school for, let's say this is 1 year after high school, and this is 2 years after high school, and 3 years after high school, and 4 years after high school. So 1 year after high school, you would expect to make $10,000 a year. If you are in school for 4 years after high school, then maybe you could be expected to make $30,000 a year. So these numbers might not be accurate, but it gives you the idea that as the number of years in school increases, then the salary expectation also increases. So it's a way to help you see what the relationship is so that you can state it like this. You could also state it in a negative way. As the number of years in school decreases, then the salary expectation also decreases. This is a direct relationship. And it doesn't matter how I state this, because these two things are the same and these two are the same. This is a direct relationship. Okay. So we did questions 1 and 2 together in class, so I'm going to do those with you together. The first one says, what type of relationship is shown in the graph below? So when I look here, I've got time on the bottom axis, on the x-axis, and it's increasing as I go from left to right. Okay. And I have height on the y-axis, and as I go up, it's increasing. As I go up the y-axis, the height is increasing. But I notice when I look here that there's a pattern, and it's going up and down. When I go over here to my input page, and I look at all of these different graphs, I should notice that this matches up with one particular graph, this one, where it's going up and down. This is a cyclic relationship. So when I come back over here, since this is asking me for the type of relationship, I'm going to say cyclic. Okay. The second question is asking me to state the relationship between time and tide height. So this is time, this is height. So this is now asking me not that whether or not this is a cyclic relationship. This is asking me to state the relationship like we did up here. So anytime you're stating the relationship, you start off and you say, as the whatever is x, this is my x, as that increases, what happens to y? So I'm going to start that off here. As the, in this case, the x-axis is time, so I'm going to say as the time increases, and they're asking me about tide height, so I'm going to say the tide height, and now I'm going to have to look at the tide height and see what's happening here. As the time goes on, the tide height here, it goes up, right? It goes from 10 to 12. So should I say increases? Well, it doesn't continue going up, does it? It goes up and then it goes down again. In fact, when I get to time of 9, it's down at 2. So does it increase or does it decrease? Aha, yeah, because look here, it's going to increase again. So this is actually increasing and decreasing, increasing and decreasing. So you could say this a couple of different ways. You could say the tide height goes up and down over and over again. If you really want to be scientific, you could say that the tide height increases and decreases repeatedly. Repeatedly means it repeats over and over again. That's a really scientific way to say that. But if you said the tide height goes up and goes down over and over again, that would be fine too. So go ahead and answer questions 3, 4, and 5. Remember, you are using your input page on page 5 to help you answer these questions. And if it says state the relationship, remember you're starting off as the whatever the x-axis is increases, what happens to the y. Now to help you with number 3, time is the x-axis, distance is the y-axis. And time is a little weird here. This is showing you 0 hours and 20 minutes, 0 hours and 50 minutes, 1 hour, 40 minutes. So if these minutes throw you off, you can actually just ignore them, okay? It's not going to affect this data at all. It's a kind of a weird way to do this. But if it does make sense to you, feel free to use that if that helps you a little bit, okay? If you are struggling with this, then feel free to email Mrs. Leonard, check in with another teammate, or come in at lunch so that way you can get some help and ask questions and get the stamp for this. Okay, I hope that helps.